welcome back to our channel. So in the previous session we have seen the operations on double linked list. So we have started the double linked list. So in that we have already covered the how to create a double linked list, how to display the nodes of a double linked list, and how to insert an element in a double linked list. So the insertion, we have seen the three cases, that is insertion at the beginning, ending and specific location. In this session we will go with the another operation, that is deletion. So how to delete an element from the double linked list. Right. So just an introduction. So just let us recall this double linked list. So here in this double linked list, every node is having two links. One holds the address of the previous node and another holds the address of the next node. Right. Now let us see the deletion operation. Deletion. So here also we will see the three cases. First let us see the logic for deleting the element from the beginning position. So let us consider a double linked list and then we will see that. See. Right. So let us take four nodes. So the node 1 is having a address location 1000, so it is 2000, it is a 3000, it is a 4000. This is the memory location, right? So three fields, every node is having previous, data and next. Here also let us have a three fields. Here also let us have a three fields. Here also let us have a three fields. See, the first one is 10, 20, 30 and 40. Yes, so in the previous node of the first element it will be null because this is the first element, right? This is the first node, so it doesn't hold the address of the next previous node. So because it is a first node, so the previous will be filled with null. And next one means it holds the address of the next one, that is 2000. So coming to this 20, it holds the address of the previous, so 1000 here, it holds the address of next 3000 here. Right. Next, coming to the 30, it holds the address of previous, so 2000, it holds the address of next, so 4000. Coming to the 40, it is the last element, so it holds the address of previous, so 3000, and it is the last element, so the next is filled with null. Right. Hope you understood. Now it is having a double link. So single linked list is having only one link, that means we can travel from starting node to ending node. The reverse process is not possible. So here it is having a double node. So both way we can travel from starting point to ending point or ending point to starting point. Right. See. So here the deletion of a node means we have to delete the data or we can disconnect the link between the nodes. Right. So the first case, deletion at beginning. Deletion at beginning. See, this is the head, this is the tail. Right. So if you delete the beginning, which element should be deleted? 10 will be deleted. Right. So 10 will be deleted, so that we have to disconnect the link between the 10 and 20, right? 10 and 20. See, automatically if you if you delete this one, this position must be null, right? And this node will be the first node, so first node previous field must be null, right? And head should be moved to here. So three cases. Hope you understood. So if you place null in this position, automatically link will be disconnected and this will be the first element. So as this node is the first element, it should not map or it should not hold the address of any other node, right? So in the previous field, so in the previous field we have to place null. So all these three cases should be done. See, first let us move the head. So just store the head in temporary variable. So now this is a temporary variable. Now move the head from this element to the next element, because after deleting the first element, second element will be the head. So that's why before disconnecting, you just move the head to the next, head of next. So after executing this one, this head will be moved to second element, right? Head is equal to head of next. Now head of next means 2000, so head is moved here. Now what we have to do, we have to place null in here. So what is the position of this one? Temp of next. So if this node is a temp of previous this one, temp of data is this one, temp of next is this one. So temp of next is equal to null. So automatically this position is null. So obviously the link between these two nodes will be removed. Or simply we can use a free function, right? So free function is used to deallocate the memory, right? So dynamic memory allocation, that is the fourth fourth function, free function, which deallocates the memory. So automatically we can free the temporary variable so that the memory will be deallocated. That's another way, right? So here we are disconnecting the link. After executing this one, the link is disconnected. So this is the double linked list with head pointing to the 20. But here the problem is, here 20 node, the previous field is holding the address of another node, right? So that's why this position also to be set to null. So what is this position? Head of previous. Head of previous is equal to null. So 1000 will be replaced. So hope you understood. This is the head of previous, head of data, head of next. Here it is null. Okay. Now you can see this. This is a double linked list after deleting the first node, that is 10. Right? Now head is pointing to the first node because previously, head of previous is null because it is not holding any other node, right? And 40 is the end because it doesn't hold any other address after this node, because tail of next is equal to null here, right? So this is a simple logic for deleting an element from the beginning, right? Now let us see. Let us consider this one. And now let us check how to delete an element from the ending. So now we have to delete an element from the end position, that is 40 should be deleted. This 40 should be deleted. So if 40 should be deleted, what is the last element? 30 is the last element. So if it is the last element, we said that the next field, that means address field of 30 should be filled with null, and tail should be moved towards its previous node. So let us take temp is equal to tail, right? Temp is equal to tail. So here this is a temp. Now move the tail to the previous. So tail is equal to tail of previous. Automatically the tail is moved to previous node. So tail is moved to previous node. So if it is a tail, the tail of next should be null. And before going to that, the temp, that means a 4000, that 40 node previous is having the holding the address of the 30, right? Here there is a 3000 which is the address of 30. That means there is still a link between the last node and the tail, temporary node and tail. Now we have to place null at the previous field of 40. So what is this one? temp of previous is equal to null. So automatically here the 3000 will be removed and null will be placed so that the link is disconnected now. Right? The link is disconnected. And then still the problem is not solved because here 30 is the last element and the next field holds the null value for the last element, but here it is holding the address of 40. So here we have to place null at the tail of next. Right. So tail of next is equal to null. So here 4000 is replaced with null. Right. Now there is a no link between the 30 and 40. So automatically the head is 20 and tail is 30. So that implies we are deleting an element at the end position. Right? Yes. So hope you understood these two cases, beginning and ending. Right. We will move on to the next one, that is how to delete an element from the specific position. See, we'll go back with the example. See, here it is a 4000, here it is a 3000, so a link, and here it is 1000, so there is a link, and here it is a 2000, there is a link, it is a head, and this one is a tail. Right. Now we will see the third case. Third case. Right. Now see, third one, deleting an element from the specified location. Excuse me. So here we need to take a value, that means we have to read a value position. So from where we have to delete the element. So we have to write the first statement, scanf %d ampersand position. So here we have to take input as of position, let it be 2 as usual. So in all the cases we are going with the 2, right? So let us take a 2 itself. So 2, second position means 0th position, first position, second position. So this position should be deleted. This position should be deleted. Right? Now see, first let us assign head to temp so that we can travel. Right? So just move the temp, because if this element is deleted, see, just observe, if this element is deleted, so what is the position of this one? So 20 of next should be the address of 4000, I mean the address of 10. Is it right? Yes. So this should be changed to 4000. And what about this one? It should hold 2000, because this is one. So if you delete this one in the absence of this, so while 20 holds the address of next one, that means 4000, and 40 holds the address of previous one, that is 2000. Right. Now we need to change these two fields. Okay. Then automatically if you change these two fields, this field will be deleted, disconnected, automatically disconnected. Right. See, first let us move the temporary variable till the position -1, because here we have to change. So for loop I is equal to 0, I less than position -1 I plus plus, just move the temporary variable. So temp is equal to temp of next. See, let us observe till this one. So if I is equal to 0, right, see, first temp is equal to head. So initially the temp is here itself. Temp is here itself, right? So okay, it's not visible for you. I will write here itself. Okay, this is the temporary variable. Now I is equal to 0. 0 less than position minus 1, 2 minus 1, that means 1, right? 0 less than 1, true. So temp is equal to temp of next. So initially temp is this one, temp of next means 2000. So temp is equal to 2000. So automatically the temp is moved to this position. Right? So temp is moved to this position. Now again I plus plus. Now I is equal to 1. So 1 less than 1 false. So just stop the iterations. Now temp is at position minus 1. Now what we have to do? We have to replace this with this one. Simply we can say that temp of next is equal to, so in this position what we have to place? 4000, right? 4000. So how this 4000 will be? Temp of next. See, so temp of next means 3000. 3000 of next means 4000. So 4000 is assigned to here. So don't get confused. Temp of next is 3000. 3000 of next means 4000. So here after executing this statement, so 3000 will be replaced with 4000. Right? Now this connection is disconnected. This connection is disconnected. Now we have to replace this one, and 4000, if it is a 4000, so it is connected here. Now we have to change this 3000. How to get this one? Temp of next means 4000. 4000 of previous. Temp of next of previous, right? Temp of next means 4000 of previous. 4000 of previous means 3000. In this position what we have to keep? We have to keep this 2000. So is equal to simply temp. So automatically in this position, instead of giving 3000, it will place it there 2000. So again this link is disconnected and it will be moved to this one. So automatically this link is discarded. I mean this node is discarded. Right? So hope you understood this one, a simple logic. So we have to replace the next and previous value. So if you are deleting the 30, the 20 element next value should map with 40 element, and the 40 element previous field should map with 20 element. So that's why we are using this one, temp of next. Temp of next means this location. To that location what we are assigning? Temp of next of next. So initially there is a 3000, temp of next is 3000, of next 3000 of next, that means 4000. So 4000 is placed at temp of next. Next we have to replace this position. What is this position? Temp of next, next of previous. So temp of next is 4000, 4000 of previous. 4000 of previous means this one, right? This position is equal to temp. Temp means 2000. So 2000 will be placed there, right? So logic is clear and a simple. Sorry, this is completely out of loop. Yeah, it ends the loop and this completely out of loop. So hope you understood this one. So how to delete an element from the specified position. So if you are having any doubts regarding this session, feel free to post your doubts in the comment section so that I will definitely try to clarify all your doubts. So in today's session we have seen how to delete an element from the beginning, how to delete an element from the ending, and how to delete an element from the specified position from the double linked list. It's somewhat very simple, right? So try to understand this simple logics, and if you really understood my session, like my sessions, share my sessions with your friends, and don't forget to subscribe to our channel. Keep following our channel. Thanks for listening. Thank you very much.